Swayam Prabha. Digital India. Educated India.
All right, so today, this morning is our last lecture. And there is some activities associated with the lecture, and then we're going to go back and start talking again a little bit more about the project, and then you have this afternoon to pull that together. Whatever you get accomplished, as I said, and I'll talk more about that later. Everybody does something a little bit different, so the expectations are not uniform across your projects, depending upon the data that you have. So we're going back to, this is just the same intro slide as yesterday, sort of figuring out this design for the environment. How do we actually do this, right? Earlier in this course, you got the philosophies and the why, but now it's the how. So design for the environment. This is how do we come up with these solutions for remanufacturing or recycling or redesign, so we don't have to do all of this in the end. So that's what design for the environment is. How do we make all those things work? I'm going to skip that one. We did that one yesterday. All right. So lots of changes, right? But this is all assuming that, well, it sort of starts with the product, right? Starts with the product and thinking about how we might product. Today, we're going to talk a little bit more about it's going to be a different product, right? Those bigger system-wide changes. How do we really think about changes? Not the tweaks, not the good housekeeping, not the use less material, right? Figure out how to make the same thing still structurally intact, but with less material. This is about how do we really think at a broad systems level about doing better. So, and as I said yesterday, this is integral from the start, ideally. Right? You've got a new product idea. You set what your design for environment objectives are. Remember, we are designed for disassembly, designed for zero water, designed for no toxic, right? So whatever those goals are, you've got to set those. You can't do all of that, but hopefully you think about this from a systems perspective. Some preliminary interpretation of environmental impacts. Some of you have that now. And then the guidelines that I shared yesterday would be what you would do in your product development. But then at the end, once you have a pilot or a prototype, you can maybe do a little more quantitative life cycle assessment. Another challenge comes when you already have a product and you want to redesign it. You want to re-engineer it to make it work. And that gets harder. But so much of what we have to do as engineering is at that level, right? Because we have all this, we're not going to just throw out everything to create new products that fit this, right? And some of the products that have been made last for decades or maybe even centuries. So we can't just throw those out and start from scratch. So re-engineering existing systems is a challenge. Some of the systems we work on right now, I shared with you New York State's climate law and intended transition to a lot more renewables. That takes re-engineering the entire electric transmission and distribution system. It just doesn't work the same as having, some really big gigawatt level thermal and nuclear power plants. You've got to re-engineer that system. So that's a little different than a new product, but it's still really, really important because we have a lot of built environment. All right, so you may have not seen this. This is just another framework, the principles of green engineering. Most of them are the same as what we've been talking about, but there's a few at the bottom that we haven't talked about. So cognizant of local geography, aspirations, and cultures, right? Systems that work in Potsdam where we have winter might be very different than systems that work here, right? Or maybe systems that work here won't work in Potsdam because of the cold climate. But it's also the cultures. As I said, food waste management at Clarkson is different because students will not they do not want to sit in the dining hall to eat. They want to take their food elsewhere. Usually it's often to a study space and they're sitting around a table with all their buddies doing their project work. So it's not like they're just going back to the dorm room and eating alone, but they are, it's a different culture. And so those solutions that work well here won't work at Clarkson. And we have to improve, innovate, and invent technologies to achieve sustainability. Well, engineers do that. And we have to actively engage communities and stakeholders. We heard that in some of the external talks, right? How important it is. Yesterday, we heard that to engage all the stakeholders, including the community, because sometimes these, even though you have a great technology, it will not work if people are not on board. All the different stakeholders are not on board. So we're going to think a little bit more about those solutions today. So a system. Yeah, so today's problems come from yesterday's solutions. And so we think that we had a great solution a decade ago or a century ago, not so great now. All right, so systems, I think you know what a system is, but it's the big, right? And that's different. And we have to think about it in terms of that. And so we have to understand the interconnectedness of the parts rather than in isolation. And that's why I think these diagrams are so important. Because you got to draw the arrows back to the start, right? Where does that arrow go back? If you're recycling, where does it go back to? You need to understand that. That's part of that system. And the user is also part of that system. And we got to recognize that we want to come up with solutions that are good for the whole system, or not too detrimental. All right, so you're mostly engineers. You've been taught about how to think like an engineer, most of you. In the red, those are sort of the words that are typically taught in engineering, right? You got to solve a problem today. You got to consider the local, focus on the technical issues. Somebody else will deal with the politics and the ethics and the environmental impacts, right? That's typical maybe not environmental engineers, but generally that's how engineers are educated and operate. In the green is the way we need to think about more if we're going to be green engineers, right? The whole system. We got to consider the non-technical. Even if you don't know how to do that, you are working closely with people. You don't just ship it off to somebody else. You work closely with them from the beginning on the non-technical side as well. You cannot bring them in at the end. You've got to consider the global context as well as the local. And that it just is very transdisciplinary, right? You've got to work with people very intimately from all sorts of disciplines. This is where we need to move towards. And this is one of the challenges that I find in engineering education, that there are other engineering faculty who don't get this, right? They still are on the left and they're not going to change. And they think all they need to do is teach, here are all the equations to design a wing of an airplane, and that's all you need to know, right? And it's just all equations and math and not about what's the product, how you use it. Is it the right thing to build, right? We do not, civil engineers do pretty well, but a lot of the other engineering disciplines don't even ask that question. Why are we even building this? Why are we even making this? That is what we need to do for this green engineering. All right, one way to do that, and I don't know if any of you have thought about this, maybe it's something to think about in your product. I'm not sure who has what, but to change from a pure product and ownership to a service. Do any of you engage in a service that maybe at some point in the past you would have owned something to do that same thing? You do your own laundry, okay? But there are, I saw laundry services here. There are laundries, maybe it's just for the visitors. Okay, let's see, what else can I think of? Services that have changed. What about, let me keep going here. So that's a service, right? So rather than you buying and putting food in your refrigerator, having to deal with cooking, right? That you are outsourcing your food supply. Advice and consulting, right? That's something that is a service. A lot of engineers, especially civil and environmental engineers, do advice and consulting. Making software, we saw that yesterday, right? You're doing the software so somebody else doesn't have to do it themselves. Product leases, rather than owning like a washing machine or a car. I don't know if that's standard here. Some people in the United States lease a car and then they have it they always want a new car. And so they lease it for 3 years and then they get a new car. It's not an economically, it's for those people who have enough money to just always need a new car. And results oriented. So this is where you outsource, is like pay per service, like computer care. I don't take care of my own computers. That's right. Right now I have Clarkson to do that for me, but some of those things are providing a service, or even leasing a computer to you, and then when it's broken, just say, I give up. I'm about that point with my computer right now, but I will be happy to go back and give it away and say, all right, take care of it. I need that service. So anyhow, the bottom line is, if not everybody has to own a washing machine, then that's a lot less material good, right? Does everybody need to have a washing machine in their stores? A library is a service-oriented, right? Owning all your books, someplace where you can share. So those sorts of things that help to enable some of those circles, the sharing, the reuse, that is one way to transition towards a circular economy, is to think about a service instead of a product that somebody owns. You are still providing the function, but the individuals do not need to own the material goods. All right, and a pure service, whoops. Pure service, like washing clothes there, is just a pure service, like a laundry facility. All right, so service systems, and actually a lot of the more developed economies are transforming from making goods to providing services. You've probably heard this happen in a lot of EU countries. United States was going that direction, now we're going backwards, but it is a service sector, like banking, financial systems, moving goods around, but not actually making them. But it does reduce. We would just, for example, with laundry, have fewer washing machines that need to be made if people used a service like that and employed other people to do that. They could do fewer, bigger batches. But it also incentivized durable products, because the provider doesn't want their products to break down, right? If you're leasing something, you want them to be durable. So anyhow, it is a way to think about a bigger system than what we were talking about yesterday, right? Yesterday, we were talking about tweaking the products and the processes and still making sort of the same stuff and still thinking about it in the same way as a product that you own and you use. Thinking about a service might be something for some of you that gets beyond that. All right. So when we think about sustainability, we've got to really get to that reinvent. That was one of the big words from yesterday. And use a broader systems potential and this really gets us towards reducing unanticipated consequences. So we've been talking mostly about optimizing an existing solution, right? How do you make a light bulb still work, but maybe with a little less material or better energy efficiency, right? Or many of you had energy efficiencies. Re-engineering the system, that's more like changing the manufacturing process, right? How do we make the system better, but it's still the same system? Ultimately, remember I showed you 3 bars yesterday, a red, a yellow, and a green, and the green was the regenerative economy. We need to redefine even what the problem is that we're trying to solve. Why are we doing this in the first place? Do we need this product? Do we need this system? What is the cause of this problem? And can we just like say, well, let's fix something else and then we won't have that problem to begin with? Those are the sorts of things that get us towards this regenerative, reinvented future. Like that line, right? I'm not convinced that's sustainable by any means, but that's reinventing, right? That's a reinventing housing and communities. So we've gone through lots of radical redesign of all sorts of stuff, you know, from stovetops to microwave, from, I don't know, you might be too young, vinyl records to cassette, the middle CDs, right? Now your music, what do you use for your music now? Your phone, right? Phone, right? Cameras. Have any of you owned a camera, a real camera? A few of you, but mostly not, right? It's all built into one. And mail, man, how many of you still send letters? My daughter does, one of my daughters does. So we've changed this a lot, right? The bottom line is, though, some of these are optimizing the existing solution, right? We've gone from dial phones, I still remember those, to push button phones, right? Microwave, like it's optimizing the existing solution. What we've done now is we all carry one device that does it all, right? This is radical redesign. It's happened over how many years? What's this trend? Maybe not from the very far left, but 30, maybe maximum. But, you know, in terms of having one, we don't call, I mean, we still call them phones, right? But they're really mobile devices. Using them as phone is probably the least relevant thing that you do with them. But our mobile devices have totally changed the way we live. Not all for the better, but that was a radical redesign, and it dematerialized, right? There's a lot of bad stuff in a phone, but we don't need to make other phones and cameras and CD players and CDs, and we don't need to deliver mail as much. So it's caused some problems, but it's also reduced some of the material good elsewhere. So we can do this. We can do radical redesign. I just want to give you a couple more. Yes, this is redefining the problem. Okay, couple more examples. So this is the Ford Motor Company in Michigan. And this was part of the sort of early cradle to cradle. So you're looking at, on the left of that photo is the manufacturing plant. I guess this just a huge assembly line, right? They make cars. You started at one end and it goes about 2 miles, a mile down the assembly line, and they keep adding to it. That's what assembly line is. And so these are really long lines where they're making automobiles. So they have changed it dramatically. All that green, that's not grass on the ground, that's a green roof. And so part of the challenge with all that roof is that water has no place to go. Rainwater is a substantial problem whenever you have impermeable surfaces, just like in our cities, right? It's the impermeable surfaces and no wetlands. So basically they're putting green roofs on. And within not a lot of time, 5 days, they had birds on their roof once they did it. It is, so I looked this up. This TED Talk is fairly old, but I just looked it up. It is still working 20 years later. So this was, you know, early cradle to cradle. And then they put solar panels over all the parking lots. So they've changed, you know, car manufacturing is not a clean business, but they're still using bad stuff in the manufacturing line, but they are really making a difference with the green roof and the solar. And that's not something you traditionally think about in terms of, you know, facilities design, but it works. Here's another one. This one's older. So this is New York City. It's a parade. The one circle in this parade is an automobile, and everything else is a horse-drawn carriage. So this was 1990. What do you think happens when you have that many horses running down Main Street? Dung, yes, whatever you want to call it, horse manure. Uh, 100,000 working horses go through New York City every day in 1900. The great horse manure crisis, right? There was a problem that they tried to solve. Anthrax, all sorts of biohazards associated with that much dung. 20,000 deaths a year because of the manure. And this is a classic environment, right? It's a bio waste. Yeah, you're right. Same thing in New York City. Or it rains, right? And then you've got all the leachate from that dung. So that middle picture is just that street filled with horse manure. And it smells, right? So anyhow, it was a big problem. So what was their solution? Automobiles. So 20 years later, it's the same parade. There's one horse-drawn carriage, and all the rest are automobiles. 20 years. New York City went from horse-drawn carriages to automobiles. And they thought this was a great environmental benefit because they solved the horse manure problem. They what? They just shifted the problem. Absolutely. They shifted the problem, right? Nobody knew about, petroleum as a limited resource. They didn't know about air pollution and its impact on public health, right? They had public health, air pollution, public health problems with the horses too, but they absolutely shifted the problem. So analogy between then and now, right? We've gone from horse manure to carbon dioxide and particulate matter and NOx and VOCs, which creates more particulate matter and smog. And so now we're talking about electric cars. I just read this morning, New York Times. We're going back to electric cars are bad in the United States. And Uber, there's a service, right? How many of you used Uber or a taxi? Right? Because you do not own your automobile, right? That's exactly an example of a switch from an owner, everybody owns, to you use the service because you don't need the car every day, right? And then you got to manage the car, you got to do your own maintenance on the car, you got to pay taxes and insurance on the car. It's much easier to use your mobile, get an Uber or a taxi or whatever is easiest here. So that's a great example of these transitions. So 20 years from horse-drawn carriages to automobiles. It's been another 100 plus years to electric vehicles. The rest of the world will keep forward with that. But the Uber, that's that service provider is really value add because there's just fewer cars we need to make or car sharing programs. So anyhow, that's think big about this. What? Drone taxis. Oh, that moves goods, right? Maybe they'll go pick up for people or for just good for people. Oh, I would, but I think they're getting used for delivery of packages and like a takeout food. Is that happening here? Not here, but that's it's I don't think I would want to do that. But I would, have a package delivered, right? And that would be better than a whole truck coming to my house to deliver a package. All right, so Uber, there's our good example of a service-oriented, right? So these changes happen and they can happen. It's hard to anticipate though the future. Like when I was young, there's no way I could have imagined mobile phones and Ubers and any of this, right? So things really do change rapidly in today's world. So our job is to think not just about, next year or even 10 years, but how can I design a product or a system that's 30 years, right? 30 plus years. That anticipatory skill set is really important for engineers. All right, so just, the part of the tinkering, like redesigning the parts, then making it more energy efficient, right? That's all part of optimizing, but it's still an automobile that often one person gets in and drives around and congests the road. So it's still optimizing the existing system. So we're going to do another breakup and thinking project here. Back to New York State. The red box is New York City. So Manhattan, New York City is big, but the where most of the Wall Street and Times Squares and those sorts of things that you hear about in New York City happen on Manhattan, which is an island. It's like Wall Street's down here, Times Square's over this great Central Park. The problem is we've got bridges. And so every day, and it's really expensive to live in Manhattan. That's another important piece. It's really expensive to live in Manhattan. And so people commute in. And so like this is New Jersey. And so a lot of people commute into New York City on these bridges. Some of it's got train, there are ferries, but a lot of it is automobiles. The congestion rivals the congestion here. Different reasons, right? There's not the motorcycles and the three-wheeled taxis going in and out, but it is very, very congested. So you can see on that bridge, very, very congested. It's all automobiles. And if you see like what it looks like maybe there's a person there, one person, they're often single occupancy vehicles as well, right? Everybody wants to drive from their house to the parking lot at their place of work. That's the convenience goal, right? So you can think everything you think about Americans and they've got to have everything perfect. That's a classic example of convenience rules, no walking required. All right, so I want you to break up into groups of 3-ish people. You can figure out how to break up, you can spread out, and to think about how do you optimize the existing solution? How would you re-engineer the system? Or how do you redefine the problem? And I want you to get to that last one too. Don't just do the easy stuff at the beginning. All right, so I give you about 10 to 15 minutes so you can break up, find a group of 3. Would you want this picture up? Maybe this is the best picture. The other picture is, and this file is in your shared drive. So if you want to go back and look at those, it's available to you if you need it. But this is the goal. How do we rethink this problem? The pavement has these deep grooves in it from where the wheels go, the years and years. They can't stop the traffic to repair, right? That's just like New York City cannot function without these bridges. And so they haven't been able to really repair the bridges because that would require closing them down. They're that bad. They'd have to do some major work. So it is a big problem in New York City. So what ideas do we have for optimizing the existing solution? Excuse me. Optimizing the existing solution. I know there was one back there. Carpooling. All right. So maybe it makes fewer cars, right? You move the same number of people, right? That's the function, is to move people. Okay, so carpooling is a great example. Any other?
Giving them a fast lane.
Okay.
We can provide separate lanes for public transport within the road. Separate fast lanes.
I think both of those are already happen. So this road has, they almost all have carpool lanes. Excuse me, high occupancy vehicle lanes. Okay, what else can we do to optimize? Okay, so that's a great one. And already rush hour traffic in New York City is like 5 a.m. to 10 a.m. in the morning. So yeah, it's because people don't want to be in the middle of this. You know, that's when at least the commuter traffic starts. The congestion doesn't start at 5 a.m. But people are trying to avoid that by doing exactly that, switching their hours. Any other? Okay, employers provide. Yep. So has anybody priced land in New York City? No more parking lots. Even, yeah, yeah, just it's totally unsustainable. Okay, somebody else said something else. Vertical park, yeah, that might be more reasonable. Okay, so but yes, you could still do some of that, and they go underground. Vertical underground is where a lot of the parking is. Okay, any re-engineer the solution. Okay, so where does that go? I right? That's redefining the problem. The problem is you've got to move people from their home to their workplace. So if you live at your workplace, you don't need. So that's an example of redefining the problem.
Space, like the land, it's not, we don't have a huge area.
Right. So this is very hard to do. This is very, very lots and lots and lots and lots and lots of dollar signs. Okay. Okay. All right, that too is sort of redefining the problem in terms of getting people onto Manhattan to go to work. All right, any other re-engineer the systems? I heard some talk about bridges and, but more build, okay.
Widening of the bridges, widening of the lanes.
I'm introducing water metro.
There are ferries. I've gone on it as a tourist. I don't know if it's a commuter thing, but there are ferries that get them. All right, build more bridges, more lanes.
Can we order everyone to take public transport?
Okay, so where is that going to be? Um,
They're already doing it. Metros are still connected in New York.
but at public transport, so we might need to then build more public transportation because they're already packed at commuting hours. So that would be part of re-engineering the systems. All right, any other ideas for redefine the problem? Hybrid, okay, so tell me more, what do you mean by that? Okay. All right, absolutely. Right, then again, we are changing the problem so that we do not need to move people from their homes outside of Manhattan onto the island for work, which is most of what the real traffic jams are employment oriented.
There is water transport.
Yep.
And some air transport facility also coming.
There are no airports on Manhattan. So you'd have to have those air drones. Air drones. Okay, so that's re-engineering the system, right? You're still moving people. Then the sky's going to get crowded. Okay, great idea. So have any of you taken a class in sort of transportation engineering? Yes, okay. What do you learn about building more roads in terms of congestion?
It's not possible to build within the city because it is so much costlier. The land becomes costlier.
Right, okay, so there are economic challenges. Any other challenges? So, All right, so we don't have land. So land access is very expensive. More pollution, right? So we're just gonna have more cars. I don't know if this is just the United States. Every project in the United States where they've like built these big belt highways around cities, they're always congested. Build more lanes, always congested. More lanes just mean more people are going to think that they can drive. And it has never been successful as a way to reduce congestion. It just means more people think that the single occupancy vehicle is the way to go. So that it just I don't know if it's human behavior doesn't work as singular. I mean, not alone. Maybe there are other ways. How else might you keep people off the roads? Something that nobody mentioned here. Any ways that you might discourage driving on the roads? Charging. So you could have tolls, right? Say that again.
Cycle ways promote cycling.
So promote cycling. So that's it again. That works great like 8 months of the year, but when the roads are icy, cycling, I know people in Potsdam who cycle all year round and it gets pretty icy and have studded tires to be safe. Okay, so we really need to redefine the problem because a lot of these other things are just really hard to do. I think it's more feasible to build more metro, like more trains, right? More frequent trains, because right now they're really like they're packed. I mean, who wants to be in a train for 30 minutes, stacked up, right? With people you don't know. So it's less comfortable than a car. Absolutely. That redefines the problem, right? Because you do not need to move people 15 miles away across onto an island. Yes, so that is a great example of redefining the problem. But it's hard to do, and that's why I said at the beginning of this, right? We've been talking about tweaking products, but part of the problem is we've got these legacy systems, our electric power grid, our cities with transportation, they need solutions too. So it's not just the new. But having learned from this, we can do better. So building more metro is probably better. The thing that they did do, and this was like a little over a year ago, is $15 per car onto the island. I don't. What's $15 in rupees? Just $15. It's like buying lunch. All right. It's like buy a cheap lunch, right? So every day, it only costs to get on the island. You can get back off. But $15, and it made a difference for congestion on the island. There's also the city streets, so that was more for congestion on the island. But obviously, those cars are not coming in, so that has helped a lot. Somebody in the federal government said, "Oh, you can't do that," but I think they're still doing it. So it is, that was one, but that's still part of the optimizing the existing solution, right? The cars still are coming on. So then they are trying to figure out, take the metro, bike, carpool. So the people have to figure out how to do all those other things, right? Maybe if you're in a car with 4 people, the $15 entry fee is not so bad, right? If you only have to drive once a week, then $15 once a week is not as bad as $15 5 times a week. So that would really, $15 really adds up. And there's a lot of charges of is very inequitable because some people can afford that, but other people who cannot afford to live in Manhattan, they live in New Jersey, the lower paid tradespeople and custodial people and public works people, they still need to get to work too. And if there's a $15 fee, that's not an equitable, financially equitable across the rich and the not so rich associated with New York City. So there are challenges with all of these. All right, so I just wanted to give you some sense of this sort of big picture thinking as well that's part of sustainability. Maybe it's a little bit beyond circular economy, right? This is the do without, right? Cut the circle, but not, get it to the point where we don't even need that circle, which you can't do with everything, but we should always be thinking about these kinds of solutions. Any other questions or comments on that? All right, so I just have a few more. So these are the higher level thinking here. So smart highways, public transportation, that's sort of the redesign, the re-engineer, and rethinking the need for mobility. The virtual office, telecommuting, we had that. Community layout, we had that. These are the systems thinking level approaches that you came up with. But in general, remember, transportation, building more lanes and more bridges often just results in more congested roads. So it somehow doesn't really work out. All right, so I just want to share, this is a part of a big picture that gives a timeline since about 1990, cradle to cradle. We talked about that in the early 2000s. And then, so what we're talking about is, the last decade or so. So the y-axis is sort of the higher up on this graph, the bigger the change and the better the change. And so in like 1990, we started down with that green engineering and green design and some of the stuff that we've talked about, cradle to cradle. It came later, but it's still down on this lower level. So this is the sort of mostly optimize. Even some of the system design. As you move up, you can see eco design, product design, there's just all sorts of weird. Design for sustainable behavior. That's a challenge that we've talked a lot about, right? We can come up with the technologies, but the sustainable behavior is harder. And so now this is the whole graph. So we just looked at this bottom level. And so we've mostly been talking in this product level, but we also talked today a little bit about moving up to the service. So back to the automobiles and the transportation, like Uber is not going to solve the congestion problem, right? It might mean that you don't need to find a place to park at either end of your travel. You don't need to park your car at home. You don't need to park wherever you're going. You don't need to own a car, but it's still a low occupancy vehicle. It's not public transportation. But then we get to the social level, design for sustainable social innovation. Some of the things like working, living communities, that's now starting to be a social change, right? That is changing the way you fundamentally live and exist in Chennai versus who lives off campus, right? So somebody who might have to commute 5 miles or 15 miles across the city. It fundamentally is changing society when you put everybody inside campus. So actually at Clarkson, we want the faculty and staff to be off campus because we want them to be using the services in the community. When you live in a small community, to keep the economic viability of the small community going, we need those people in the villages, not spending their money on campus. So, but that depends. And then finally, these big innovations and transitions, right? The horse-drawn buggies to automobiles, those are big, big changes. Your mobile phone, all of those are these big, big changes that change fundamentally how we exist socially with our technology. So these things have happened. So your job to be a part of that is to think about how do we anticipate what we need to be working on. I don't know that air drones, right, are the best thing. Now our skies are going to be, yeah, and then there's no roads and stop signs and traffic lights and drive on the left and right, all those things are, they're going to be a free-for-all up there with air drones. So maybe, but those are questions we should ask and really think through all of those potential consequences of whatever new things that we are doing. So that is the end of sort of the lecture, give you information. Are there any questions on that? Some of you might be able to think, challenge yourself to think a little bit about this for your project. Some of you, it just won't work, but it might work to think a little bit above and beyond rather than just the tweaking, right? But mostly we've been down in, this sort of down at the lowest end. That's what we've been doing in this introduction with a little bit of thinking bigger. But so if your projects just stay in the lower end, that is okay. All right, so we have 10 minutes or 8 minutes before our break. So big picture for pollution prevention, right? That's the non-toxic substitutes, reducing your waste, design for the environment, right? That includes the tweaking, the optimizing, but should also include re-engineering the system and bigger. You've got to get to like this redefining the problem into the future. And think about the whole system. Whatever you're doing for all your projects, think about what is the overall system in which this product is being used. And then we also have to always think about the social dimension and the economic dimensions, not just the technical, right? And sometimes it's hard for engineers to do, but at least we qualitatively need to think through the what ifs we made this change. So that's the end of the course. I do have one slide on your project work. And then after our snack, we'll start in general talking about the whole expectations for your project to make sure you're on. So what you're supposed to be thinking about to get to is what aspects of design for the environment can you consider to improve your product or processes? In order to get there, we needed to do some life cycle thinking and some life cycle quantitation, right? Thinking about what are the impacts, life cycle environmental impacts associated with your product. So you had to do that first, but now we're on the using that information to do some design for the environment thinking. It can be any level of optimization or redefine the problem. And then once you think about having some different options, so maybe you come up with 3 or 4 ideas for making this product better, this process better. How do you evaluate the environmental benefits? And today we're really only going to evaluate those qualitatively. We don't have time to do a whole nother life cycle assessment, right? Maybe you can say, well, we expect this to cut the greenhouse gas emissions of this life cycle stage in half. Maybe you can get to that, but as less expected. So one tool that you can use, this is called a weighted objectives table. Does something like this look familiar to any of you? Our undergraduate capstone students use this a lot. So it's a qualitative way for you to evaluate ideas. So let's say you come up with 3 or 4 ideas for improving your system. And then these are sort of your criteria for improvement. And as an engineer, the first criteria is usually it works. It's a technically viable solution, right? It works. It's not gonna, right? But then you might have other criteria. Is it greenhouse gas emissions. These don't have to be, maybe it's durability, waste generated, toxicity. Any of those can be criteria or these design priorities. So for those, you would put them in order of priority and you would give them a weight. This is very subjective. And if it helps, if they sum equals 10 or 100, then you sort of can use percentages. All right, so you have some weights. So your highest priority, right? Technically it works. Maybe is always a high. The cost should be on here. Social acceptance. Those could all be examples of the things that you're looking for in your solution. And they should be based on what you found challenging, or at least partly challenging with your product through your life cycle assessment. So use that. So it should be, you know, informed, data informed to come up with your priorities. So you do that. And then for each idea, so again, we have subjective scores. Oh, this one's the best. I'm going to give it a 5. This one's not so good. I'm going to give it a 1. So subjective scores to sort of compare across your columns. So you can see here for design brief priority 1, idea 3 was the best in everything, right? It has the highest score. So this score is not the sum of the column. This is the sum of the weight times the column score. This is just a typical, a very, very often used, you know, early in the design process way to come up with what idea I want to recommend. So in this case, based on this numbers, 60 is the highest score. I would recommend idea 3. It's a tool. You don't have to use it, but it's a way to at least early, when you don't have a lot of hard data, right? It's still somewhat subjective, but that's still okay, as long as it's sort of informed by your life cycle assessment and informed by the improvements that you think your ideas will make. So this afternoon, hopefully finish up your thinking about what are the life cycle impacts and moving forward to what are our ideas for, and even after, if we've got an hour or so after lunch before, and then finish up that life cycle thinking about the problems and then what are our solutions. I just wanted to talk about this weighted objectives table. It looked like Bindu had done this before, maybe a few others. All right. 4 primary steps that we're doing. The first was to really think through the schematics, right? What we did on day 2, sort of drew it out. And I know several of you have added to that on Tuesday. Then the life cycle assessment part, step 2. Now this is where you all have different information. Some of you have results, right? Like the automobiles, wherever the automobile group is, right? You had actual life cycle impact assessment, or at least life cycle inventory results. You just had to do the math to apply it to whatever vehicle you wanted to look at. So that was pretty easy. Some of you don't have life cycle impact assessment results, but you know all the materials that were used and maybe the energy in manufacturing or use. So what we have for you to look at are those spreadsheets that you can look for the materials that you have and find either energy and carbon dioxide on one of the spreadsheets or more life cycle impact categories on the other spreadsheet. The 2 spreadsheets sometimes have different materials. So it's not perfect, but at least it would give you some idea of, from a materials perspective. And so hopefully you've got, and in all cases, there's some math, right? Some just the algebra to say, you know, if this is my functional unit, how much of these different things do I need, right? So that math to figure, and I think you're all pretty much in good shape for that. And now, hopefully, today, this afternoon, maybe starting now, maybe this morning, you can wrap up the life cycle thinking part to start thinking about what are we going to do to make the system better. And what we're really hoping that you do is at least to come up with ideas that you can say, this will increase or decrease some of these different challenges, but you don't necessarily need to quantify them, but need to understand the impact of those options enough to do something like that weighted objective table that I showed you. And that's just one tool. You can do other ways, but we're hoping for 2, 3, 4 different ideas for improvement, and that you compare those ideas so that you can come up with a recommendation. And so your final sort of expectation is, here's the current product or comparison, right? This is what we know about its life cycle environmental impacts. This is where the big problems are. Therefore, we're going to target the energy use at the user side because that's where the biggest impacts are. But it might be materials use for some of you, but that's the biggest impact. And here are the improvements that we are trying to make. And this is the improvement we want to recommend. That's really what we want you to accomplish. So that's the overview, these 4 steps. And then throughout this is just the sort of the process, the things to think about as you go through this. So steps 1 and 2, we did last week on Tuesday. Step 3, we started to do on this week, Tuesday. And these were the spreadsheets, this spreadsheet, and this spreadsheet. They both have, this one has a template that you can use to organize your materials. This one has tabs on it and pages where you can put your results in. You don't have to do that. But using a spreadsheet is often a good way to do your math, right? I've seen a lot of notebooks with a lot of math, but then you have to do more math in your notebook, and getting that into a spreadsheet, especially when you start to change things, that it makes the math easier, right? And then if you made a mistake, spreadsheets fix themselves quickly. All right, so there's all sorts of, and if you don't know, you can at least consider the toxicity. You know, if you can't, like mercury in a CFL, right? That is a known bad actor. So that's something to consider when you're thinking about improvement, to get rid of those things that you know are toxic in there. So that's where hopefully you should be wrapping that up, so that we are now moving on steps 4 and 5. All right, are there, and then the end of this, it says 30 minutes. It's that you don't really need to worry about that. But the goal is tomorrow morning, might give you a little bit of time to wrap up and, you know, regroup, is that each group, so how many groups do we have? 6, okay. So tomorrow morning, up to 10 minutes, so maybe 8 to 10 minutes presentation from your group, not from an individual, hopefully from your group, where you define what your product is, what your functional unit is and why. Here's the process. Here are the life cycle impact results, whatever you were able to do with the information you had. Here are, and then that tells you, right? That's your data informed. Here's the biggest problem. Here's my priority to fix. And then what are you going to do to fix that worst problem? Right? So that's, I want you to understand that value of the LCA. Right? We're not going to fix all the problems, but we want you to focus on what the data tells you about the biggest problems. What are your ideas for fixing that? And what's your recommendation and why? in 10 minutes. Maybe with 6 groups, we said 10 minutes before we knew how many groups we were going to have. Maybe it's a minute or two over 10 minutes. I don't think we're going to yank you off the stage, but if it goes much beyond 12 minutes, we will yank you off the stage. All right. And I think Bindu's not here, but maybe who's one of the TAs? We make a folder in that shared, a folder for them to put their presentations in that shared folder, so that by tomorrow morning you can get it into there. So are there any questions on that scope? Is this doable? This is intended to be a learning, not a stressful, right? To give you an opportunity to learn. So part of this is recognizing that you are not going to be able to do everything, right? We know that you're not going to be able to do everything in a life cycle assessment. You have to also accept that and move on. So don't stress too much about you can't do this part or that part. We recognize that. But I know you have to recognize that too, rather than stressing about it. Just say, circle it, couldn't do it. So that's something else that you can add to this communication is the limitations of your work. What weren't you able to do that you think might have been important if you were to do this with more time?